everyone, welcome to this webinar on dynamic programming. My name is Rajit Jan and I'm an ex-Microsoft software engineer, and I also run a programming YouTube channel that goes by the name Algorithms with Rajit. And in the world of competitive programming, I have been active on Codeforces and CodeChef, and my handle is Rajit IITR. So if you want to check that out. Also, I'm an electrical engineer and a self-taught programmer, and I love to teach. And that's one of the reasons why we are watching this together. All right, so I hope this was a brief background about me that painted a little picture about my expertise in this field. And hopefully it also encourages you to ask more questions and also arrange what kind of questions that you can ask me at the end of this webinar. And in this is like my YouTube channel, and if you are watching this, probably you are passionate about coding interviews, so make sure you check this out as well. And now let's dive into dynamic programming. So in this particular webinar, I have designed this for mixed audience, as in there are fresh engineers who are just into their first year, and they are like really scared about this overall topic. And there are also a lot of programmers, like for example, when I started my journey with competitive programming, it was horrible for me to get started with dynamic programming. And this is also targeted for those programmers who feel that they are not very powerful in this particular concept. And hopefully with this webinar, as we end this, as we come to the end of this, you would probably in a much better shape in tackling this overall concept and the problems associated with it. So one important thing that I would like to stress over here is that if throughout this webinar if there is something that you do not get very right away, I would encourage you to be more attentive first of all. And even if you are trying your best, I would say that it's okay, because dynamic programming is a journey, and to reach to that level wherein you are very much fluent with this concept and able to handle the questions in a very thorough fashion, I would say that it takes time. So don't be scared if something is not making that much sense. And as you make progress with dynamic programming, you can always revisit this webinar, because this is getting recorded. And thanks to HackerEarth for inviting me over here, first of all. So I would really encourage you to watch this video again later on, so that you can finally understand this particular concept of dynamic programming. So again, to understand dynamic programming, I would say in terms of a life lesson, like as an old guy giving life lesson, although I'm not an old guy, but I would describe it as something as a technique of not repeating the mistakes that you have already made in the past. And the real essence of dynamic programming comes in recurrence. And what I would say is that what makes dynamic programming very tough is this part wherein you have to understand recurrence and also come up with the recurrence equations. All right. So in this particular webinar, we'll first be focusing a little bit on what exactly recurrence is and how does it correlate with dynamic programming. And also I will try to wrap up your head around how you can approach dynamic programming problems using recurrence. So the most famous example to explain recurrence is Fibonacci sequence, wherein the first two terms are 0 and 1, after which every term coming in the sequence is nothing but the sum of last two terms. All right. And in this case, you can see like 0, 1, 1, 2, 3, 5. I'm sure that you must have heard and seen Fibonacci sequence previously. So it's okay to do this computation for very short numbers. Like if I ask you to give me the seventh Fibonacci number, probably you could do that. But as we go for longer numbers, of course, we need to write program. And this is a very easy recursive formula wherein we are using this function f, which takes an argument as n. And the responsibility of this function is to return the nth number in the Fibonacci sequence. So for example, if you call f of 6, it should ideally return the sixth number in the Fibonacci sequence, which in this case should be 0, 1, 1, 2, 3, 5. So it should be 5, because 5 is the sixth number in the sequence. So this is a very simple recursive function, and all the recursive functions look like this, wherein you have this function name, the arguments, and then you have the base cases. In this case, the first 4 lines are the base cases. And finally, you make those recursive calls to the same function with different parameters. In this case, we are calling the same function f with n-1 and n-2. And then the essence is that to make recursive calls, and when we get back the results for those recursive calls, we use them in some fashion so that we can do some computation on them and finally answer the answer to f of n. All right. So in this case, simply adding the n minus 1 and n minus 2 helps us and give us the correct answer. So in terms of recursion, what happens is that when you call call any function, recursive function, in this case f, in this case we are calling f of n minus 1 and f of n minus 2, right? So in recursion, it does not happen that as soon as f of n minus 1 is invoked, f of n minus 2 is invoked, right? Because recursion, it goes like it gives preference to depth. So as soon as f of n minus 1 is invoked, it will invoke f of n minus 2 and n minus 3. Again, before going to n minus 3, we'll first deep dive into n minus 2 and so on. So once the entire subtree for f of n minus 1, I mean the entire computation for f of n minus 1 has been completed, we finally get the answer as x. That's what it has returned. And similarly, once we got this, we go loop into n minus 2 and start the recurrence tree for that. And once the entire computations for f of n minus 2 have happened, we get the value y. And now, and only now, we are in the position to finally give you the answer for f of n. In this case, it would be x plus y. Okay, so this is how recursion works in practice. And the next subsequent slides, whenever you see red values, they are nothing but telling you what are the values which are returned when we make those calls. So if we try to visualize the recursion tree for f of 6, in every node, we will bifurcate into two separate ways, calling for n minus 1 and n minus 2. And the values in red are telling you the answer. So for f of 6, as we have discussed 2 minutes before, the answer was 5, which is signified by the red value over here. So in this diagram, from 6, we are going to 5 and 4. For 5, we are going to 4 and 3, and so on. So in this case, the base cases are very important, and they are represented in this diagram in the green nodes that you are seeing. Okay. So the green nodes are telling you what are the base cases. In our case, the base case were when n is 1 or 2. And for that, we are returning the values either 0 or 1, depending on whether it's 1 or 2. And once we have the values for any n minus 1 and n minus 2 values, so once we have those red, we use them, add them to finally give you the value of f of 4. Then when we have the value of f of 3, and so on, in this fashion, we go all the way to 6, and we finally get that 5. And here is a simple video that demonstrates how this recursion is working in real time. So we call for f of 6, and this is how we are invoking n minus 1, which calls n minus 2, so on until we hit a base case. So I'll just let you watch this video and try to wrap your heads around recursion. So yeah, you can see we are still computing the answer of f of 6. Now we are in the right subtree, which is computing the answer of f of 4. And now we have it. And finally, we got the value of f of 6 as 5. So the blue nodes are something which we have not talked about really. And the blue nodes are nothing but telling you that these are those nodes which we have already revisited in the past. In this case, as you can see, this 3, 2, 1, like this 3 blue node is already occurring previously. And just to focus on this bigger subtree as well, this entire subtree is occurring over here as well, if you can see, right? So recursion is one basic part of dynamic programming. And the second part is nothing but avoiding the recomputation of these blue nodes. And that's what I like to call, do not make the mistakes that you have made in the past. All right. So this entire subtree could have been avoided because we anyways know that for f of 4, the answer is 2 in the red, as you can see. And this entire subtree could have been avoided. So this is the main basic essence of dynamic programming. And in the next few slides, we'll try to do some basic problems, walk through how do we come up with a recurrence, how do we use dynamic programming, time optimization to finally get rid of the recomputation that we are doing. All right. So what we saw right now was how to write a recursive function for computing the nth Fibonacci number. And the time complexity for that is exponential right now because we are doing the recomputation for every blue node, right? So in the next few slides, as I have discussed, let's start solving few problems. And the first problem that I have is the staircase problem. Very easy, very famous problem, wherein you have a monkey and he has to climb n stairs, and you have to count the different number of ways in which he can climb them. Okay, so the catch is that in one move he can either climb 2 stairs or 3 stairs or 5 stairs. Okay, and just to give an example, if he has to climb, let's say 4 stairs, which means n is 4, there is exactly one way to climb Okay, the monkey has to take the first jump of 2 followed by a jump of 2. If he takes the first jump of 3, then it's impossible for him to take a jump of 1, right? So for making for making a jump of 4 stairs, he has exactly a single way of doing that. Similarly, for n equals 5, we have actually 3 ways. He can take a first jump of 2 followed by a 3, or he could take a first jump of 3 followed by a 2, or he could take just a single jump of 5. Okay. Similarly, for n equal to 7, you can basically use pen and paper to find out how many ways are there. Now, the homework for you is to count this for n equals 10. So if the monkey has to climb 10 stairs, how many ways are there? So one of the ways is 2, 2, 2, 2, 2. So he takes 5 jumps, and in each jump he is jumping 2 stairs. So that's one of the ways. And there are so many ways, right? And if I ask you to write an algorithm or a function that takes an argument as n and it returns me exactly the number of ways, different ways the monkey can basically climb those n stairs. So how would you go about solving this? Okay, this is the problem that we are focusing. I'll just give you a few seconds to sink into the problem, and then we'll proceed with the solution. I mean, I hope you can see the examples and the problem is very clear. So let's move forward with the solution. All right, so this is the recursive solution for this particular function f, and the first 6 lines are handling the base cases, and then in the final line we are returning the answer as f of n minus 2 plus f of n minus 3 plus f of n minus 5. And so these base cases, I think they are very trivial. So if n is less than 2, which means the monkey has to climb less than 2 stairs, it's impossible for him, right? Because it the monkey has to climb at least 2, 3, or 5 stairs. So that's 0. If it's 2 or 3, then he has exactly one way to jump. And if n is 5, as we saw in the previous case, there are 3 ways of doing that. And other than that, we can, of course, use the recursive function and come up with this recurrence equation. If you are starting with dynamic programming, this is like really difficult to wrap around your head with. I mean, for any given problem, how do we ensure that, I mean, base cases are okay, but how do you ensure that this recurrence is absolutely correct and this is working? So I would really encourage you to think about such questions, even if you're making a guesswork and you are trying to basically submit the solution and it's working. It's very easy as a human to move on and solve more problems because you have solved it. But take a stop over there and try to analyze and ask questions that why is this working? And it's also very important skill to develop that you're able to explain to the interviewer as well in terms of coding interviews that why this is working. Okay. So if most of you have not understood why this is working, allow me to explain you that. Now let's consider the case that the monkey has to climb 100 stairs and we have to count how many different ways of doing that are there. Now, first thing that I do is I really give huge responsibility to this function f that, hey, I'm going to pass you a number n. In this case, I'm going to pass you 100. And you have to count the all possible ways, exactly and totally all unique ways for this monkey to climb those 100 stairs by using the jumps of 2, 3, and 5. Okay. So first I enable this trust with this function. The next thing is I see what are my various options. So in this case, the monkey can take the first jump in 3 ways. The first jump can be offered 2, and now he has to climb 98 more stairs. So he can climb so basically he can climb those 98 stairs in a lot of different ways. He can do something like 2, 2, 2, 2, 2, then 3, 5, 2, something like that. So there are a lot of different ways. And I was not able to count for 100. Now how do I count for 98? How is this helping me? So let's say for now, just take a pause, and let's say we assume that to climb those 98 more stairs, we have total of 999 ways to do that. Okay, I'm just making this up. It's an assumption. I'm just pausing myself from this total havoc situation, and I'm just assuming that if I take the first jump of 2, let's say there are 999 other ways for me to climb the remaining 98 stairs. Okay, all right. Next, I can take a jump of 3, right? I mean, not me, I'm not a monkey, but the monkey can take a jump of 3, and now he has to climb 97 more stairs. Okay. And let's say again he can do that in a variety of ways, like 2, 2, 2, then 3, 5, then a jump of 2 followed by 5, and so many again, right? I again don't know that now, but let's say we know that already, and there are 888 ways to do that. Okay, I'm again making this up. And lastly, he can take a first jump of 5, and now he has to climb 95 more stairs, right? Again, I don't know the answer for how many different ways we can do that, but let's say the answer for that is 777 ways. So now take a pause and see, can you answer the question that how many different ways are there for the monkey to climb 100 stairs? Okay. And the answer is yes, we actually know now. And it's the sum of all these three different combinations that we have seen. So 100 stairs can be climbed in the sum of 999 plus 888 plus 777 ways. And ideally, these numbers 999 I have made up, but we could find them exactly if we call f of 98. And triple eight is nothing but f of 97, because f of n is having that trust with us that it will exactly and totally give us the unique ways there are to climb those n stairs, right? So f of n is nothing but the sum of f of n minus 2, n minus 3, and n minus 5. And I hope now this code makes entire sense to you now, why this, like, we are handling the base cases and then a simple one liner that f of n is f of n minus 2, n minus 3, and n minus 5. I hope this is very interesting and all of a sudden it makes sense to you if it was not making sense previously. And now let's try to see the recursion tree for f of 10. So now if the monkey has to climb 10 stairs, this is what will happen when we call f of 10. And again, the green nodes are signifying the base cases, which are in our case any number n which is less than 5. And what I can see also is that there is also a blue node, which is 4, right? So in our base case, we had something like 2, 3, and 5. And for 4, we are doing the computation, all right? So what we can see is that 4 is a blue node, which means that it's somewhere already visited. And we can see on the bottom left side, we actually have visited 4 previously. All right, so in this case, we can see that the blue number of blue nodes is very less. So using recursion or using dynamic programming won't make much difference. But as we will see later on, there will be a lot of blue nodes which will be introduced when we call this function f for higher values of n. Right now, we are calling just for 10. And the answer for 10 is 14, and it would have been really difficult for us to basically count the various ways the monkey can make those jumps. And that's what I really love about dynamic programming. Like, we did not have to come up with some formula like it should be 3n plus 2 to the power n, something like that. We simply have to worry about recursive formula that we will be using, and it will exactly solve us and give us the correct answer, of course, if we implement it correctly. So let's try to wrap our heads around how this is working. And for n equal to 7, we have seen that there were 5 ways initially. And let's try to see if this recurrence tree is also conveying the same message. Okay. So for 7, hopefully you can see in the red, the answer is 5, which means that when you call f of 7, 5 is returned. Okay. So again, the red values are signifying what is the answer returned when you make the recursive call to f of n, right? So for f of 5, it's saying 3. And for the blue node, f of 4, it's saying 1. Okay. So now let's try to understand why f of 7 is 5 and whether it's making sense. So for n equal to 7, we have the following ways like 2 to 3, 2, 3, 2, or 2, 5. Then we have 3 to 2 and 5 2, right? So there are 5 different ways for the monkey to make these jumps and finally climb 7 stairs. So again, the first jump could be of 2 or 3 or 5, right? And when we make the first jump of 2, remaining stairs are 5. And to count the various ways, we call f of 5. When we make the first jump of 3, the remaining stairs are 4. And we basically use f of 4 to give us the variety of ways the monkey can do that. And then the first jump can be of 5, remaining stairs are 2, and we call f of 2. Okay. So here is this interesting part. So these 3 ways where the first jump is of 2 is exactly captured over here in the red, right? And when the first jump is of 3, this 3 to 2 jump is also counted exactly once in this one that we are returning for f of 4. And lastly, the monkey could take a jump of 5, the remaining stairs were 2. There was single way of doing that, which is again counted once over here. So you see how beautifully this is working. Like, we didn't have to come up with the exact formula in terms of 2 to the power n or something like that. And it's working so beautifully. Each and every possible case is being captured in some way or the other in n minus 2, n minus 3, or n minus 5. And we basically sum these 3, 1, and 1 to finally get the answer for f of 7 as 5. And this is the recursion tree for f of 20. and hopefully now you can see a lot of blue nodes, and make sure that every blue node is having its entire subtree. I mean, in this case, every node is bifurcating into 3 branches. So the entire subtree starting from, let's say, any blue node would be blue, right? Because we have already revisited those nodes, and the entire subtree could have been avoided to recompute again and again. And now I hope you can see that the time complexity from exponential to polynomial would be a great success, right? And we could have avoided a lot of recomputation if we were using dynamic programming, which we are not using right now, but we are 50% through, because we are past 80% of the solution, because coming up with this recursive formula was very difficult. Okay, so dynamic programming is exactly recurrence but on steroids. Okay, and if few of you are like web developers, you might be familiar with the concept of caching. And what essentially happens is that if we have already computed the answer for something in the past, we simply return it instead of doing the computation again and again. We'll see in a while how exactly this is introduced in the recursive solution. But before that, I want you to walk through with another example, so that we are much clear with how this recursion step is working. All right, so another problem is on strings, and the problem is something like this. We have to count the different number of strings of length n, and we can use two alphabets a and b. All right, the only condition is that we are not counting those strings in which the letter a comes twice. So basically the letter a should not repeat. Okay, it can come a and the immediate next character should be b, so no two a's can come together. Just to make this a bit more clearer, let's understand few examples. So for n equals 1, there are two ways, like two strings a and b. For n equal to 2, so basically for a strings of length 2, there are three possible ways. We can have a string ab, or ba, or bb. Okay, we would not count AA over here, and the answer for this would be 3. Now, if I ask the answer for 10, there would be a lot of different strings, right? I mean, if we remove this condition of 2a's, there would be 2 to the power 10 different strings that we can make of length n, because 2 to the power 10 is, I think, 1024. So yeah, it would be really difficult for us on paper to figure out of those 1000, I mean, approximately 1000 strings, we have to eliminate those strings wherein two A's are coming together, which is a very tedious task. And if we have to talk about a recursive solution for this, we could propose something like this. And I think this would be very weird to see like what's going on. Just let me read it first, and we will try to work our heads around this. Okay, so let f of n comma 0 be the number of valid strings of length n that start with a. Okay, and let f of n comma 1 be the number of valid strings of length n that are starting with b. Okay, so if I ask you that how many, what would be the answer for length 100, it would be f of 100 comma 0 plus f of 100 comma 1, right? And how do we basically come up with these recursive equations that we are seeing in front of us? That's another question. And in this case, it might be a bit difficult to understand what is happening with the zeros and ones. And probably if during coding interviews, it might also happen that the problem that is given to you, you kind of solved it using dynamic programming, and there might be a different solution, maybe a greedy one. And the interviewer is kind of surprised to see this dynamic programming solution that you have proposed, and it is correct. But the problem is whether you are able to explain it to him. And if you try to do something like this and it's a bit cumbersome, you are seeing that the interviewer is not able to pick this up. You should be able to, at that point of time, calm down and try to walk him through what you're thinking. So in this case, if it's not making much sense, uh, let's try to remove the zeros and ones and try to use the characters a and b. Okay, when we start coding it, we will of course not use a and b at that point of time, but just to make things simpler to understand. Okay, so f of n comma a is the number of valid strings of length n that start with a, and the formula for that is f of n minus 1 comma b. It's exactly that, and we will come to see how this is working in just a few seconds. And f of n comma b is f of n minus 1 comma a plus f of n minus 1 comma b. And and you should have this capability to explain why this is true. Okay, so now let's try to understand why f of n comma a is f of n minus 1 comma b, and why the contribution of f of n minus 1 comma a is 0. All right, and the basic essence is nothing but you're counting the strings of length n which are starting with a, right? So if you have filled an a, and when two a's can't come together, you are forced to write a b, right? So the remaining n minus 1 characters will start with b. So the remaining string has to start with b, and it can never start with a, and that's why the contribution of f of n minus 1 comma a is 0. Just to make this a bit more clearer, let's say we have n spaces and we are counting all different strings that we can make with using a and b alphabets such that no two a's come together, and we are counting f of n comma a, which means that it has to start with an a. All right, what next? So if you try to fill in another a, it's not allowed, because that's what the condition was, no two a's can come together. So you're forced to write a b, right? And in the remaining n minus 2 places you can fill in a lot of stuff, and it's difficult for us to figure that out, but we can use f of n minus 1 comma b to get that answer, right? We are having this trust in function that f of n minus 1 comma b will exactly count and give us the number of possible strings of length n minus 1 that start with b, and that is why f of n comma a is exactly and precisely equal to f of n minus 1 comma b, and f of n minus 1 comma a can never ever contribute. Okay, so now I hope this recursive equation makes much more sense, and let's try to understand this implementation that we have. So I'm having a function count that takes the length and the starting character, and if n is 1, which is the base case, the length is 1, you can fill a or b, we don't care, and the answer for that is 2. But if you are starting with a, then the count of that is nothing but n minus 1 comma b, because you are now forced to write b in the remaining n minus, so the remaining n minus 1 strings have to start with b, and that's exactly we are counting by n minus 1 comma b. And if you want to start with b, you can simply return the count of n minus 1 comma a plus count of n minus 1 comma b. And I hope this is making much more sense now, just because of the previous slide. And again, the time complexity for this is pretty bad right now because we are just using a recursive solution. It's correct though, but it's super slow. It's exponential. And dynamic programming is finally recurrence on steroids. And I would like to show you how you can convert this into a real dynamic programming solution with a perfect time complexity, reducing from exponential to a polynomial one. So this is how we can do it. And just to focus on the main changes that we have done in the code, we have a dp global variable, which is a 2D array initialized with negative ones. All right, it's completely negative one. And we are having this function count, everything is same, base case is over there. This is something different. What we are trying to do over here is we are checking in this 2D variable that we have, we are calling the dpn comma start, right? So we are extracting the value of that in our answer, which is a reference to this. And if answer is not negative 1, it means that we have already visited this in the past. We simply return it. We do not make the recursive calls anymore. So in this case, whenever we reach the blue node in the recurrence tree, the dpn start for that would already be filled. Okay, for blue nodes, we already have done the work and we know the answer for them. So the answer for them would not be negative 1. And when it's the case, we simply return. We do not make recursive calls. And you have to store that somewhere, right? So whenever you are returning the answer in your recursive function, before returning, just store it in the answer variable. Okay, and it's a reference. Okay, so it's a reference. Okay, whenever you make changes to the answer variable, the dpn start will be affected, so that next time when you enter a blue node, the dpn start would be filled, it won't be negative 1. And in this way, you are wrapped up and you have converted the exponential time complexity into a polynomial one. Okay, you're not doing the recomputation for those blue nodes. It is super easy this way to basically handle dynamic programming questions, like thinking about the recursive solution works and just trying to make it pass for smaller test cases for, let's say, n equal to 3 or 4. And if it works, you can simply introduce this dynamic programming stuff, like just have a global array or something, initialize it with negative 1 or something, and before making the recursive calls, just ensure that if you have already computed the answer for that, return it. Okay. All right. So I hope we are almost through the webinar and we are almost clear how these recursive functions are working and helping us to tackle dynamic programming problems. And at last, I would say don't repeat the mistakes. So if it's so easy to handle dynamic programming question, then why is it so hard? And the hardness comes from the recursion part. Okay, it's very difficult to come up with a state. Like in previous case, we were having a 2D state wherein we are having a length, and as well as what are we starting with, 0 representing A and 1 representing B. So sometimes it's difficult to come up with like why are having a 2D state, why we are having a 1D state, why are we having a 3D state. Okay, so sometimes it's a bit difficult, especially when you are a beginner. It's quite difficult to think what your state should be. And another difference or another difficult thing is to basically how to make those recursive calls, how to come up with a recursive equation such that we exactly get the answer that we want. Okay, and it's quite easy to get misaligned and go on a separate tangent, and only when you submit your answer and you get a wrong answer, it's only then when you realize that there is something wrong. And in terms of coding interviews, it's an epic fail, because in coding interviews you're not having like any judge system where you can simply run what you are thinking and see if it's passing the test cases. So you really have to stop yourself from basically just writing and submitting solutions and seeing whether they work. You also have to develop this skill where you are questioning yourself like why this approach is working, and be decisive and have a good accuracy in terms of whether you are coming to a correct decision of whether it's correct or not. Okay, so that accuracy is very much important, and that's something which will reflect very strongly in your coding interviews, that you are not just trying out or guessing out things. You actually know the math behind it, why it's working. So I would highly encourage you to take things slowly, and whenever you have time, try to do small, like as we have seen in the previous problem also, we have done those recursive functions. We saw that how f of 7 was 5, and how each and exactly every possible way was in some way counted in f of n minus 2 or n minus 3 or n minus 5. So do all those stuff as you practice, and it will really help you a lot. All right. Okay, so another difficulty which arises in dynamic programming is the different types of dynamic programmings that exist over there. For Fibonacci one, there was a single 1D DP. For like the previous problem, the strings one, we were having multi-dimensional DP, like the 2D DP that we were having. We also have DP with matrix exponentiation, which really improves the time complexity from polynomial to logarithmic. And we also have different ways like DP on trees. Now, trees and graphs are something which are picked up by students very late in their engineering, or even when you are programmer or software engineer, this stuff gets basically not touched that much frequently. And DP on trees is something which is a very new world. And I also have few videos on my YouTube channel about them. And it's also very interesting and fascinating to see a simple idea of using recursion with that caching stuff to solve so many different problems. And it's quite fun, I would say. So we also have digit dynamic programming. We also have DP optimizations, and there is just a vast entire list that I have still not covered in this slide. So that's what makes DP very difficult. And just to give you an example, we can solve a variety of problems. Like for example, there are sometimes counting problems that you have to count the different numbers from range L to R, where in those numbers 0 occurs A0 times, 1 occurs A1 times, so and on, 9 occurs A9 times. So A0, A1, A2, and A9 is our input, and we have to count the different numbers in the range L to R that satisfy this. Okay. Now, if I say you that post this webinar, you should be able to solve this, of course, it would be a lie. This is something which you can solve using digit dynamic programming. And this is, again, I'm basically sharing this with you just to highlight why this is hard. And it needs a lot of practice to wrap your hands around the different kinds of states and how to use those states to basically come up with some recursive equation. Okay. Another problem can be for a given tree of n nodes, you have to print n lines where every line is containing the diameter of the tree if the ith node was the root of the node. Okay. So I don't want to go or deep dive into these problems, but what I want to convey is that Even if you are good with dynamic programming, maybe you're not good with trees, and that's why you're not able to solve problems. So dynamic programming is, I mean, one of the very hard topics I have seen in competitive programming, and even few red coders on competitive programming face it difficult sometimes. And I hope this video was fun and this webinar was super useful in terms of understanding how this gets, how dynamic programming works and the basic essence behind it. And I would say be optimistic and learn on the fly. Okay, everyone goes through this. It's a journey. No one is born very smart that they know how this is working. It takes time, but enjoy that and try to, don't just make jumps. Okay, we are not monkeys. Don't make jumps. Take things slowly. Try to question why this is working, and I'm sure this would really work very well for you. And in most of the cases, if you are like really preparing for coding interviews, I would say just using this recurrence relation and base case terminology would really help you a lot. I mean, there is also like dynamic programming can be of multiple ways, top down or bottom to up. So I'm not discussing that, and I really do not like that bookish knowledge. If I have to introduce dynamic programming, this is the way I would introduce. And I hope those other things are some things which you can learn by reading on internet or something like that. But I mean, in terms of coding interviews, you should use this recursive solutions followed by the generating of base cases, correct base cases, handling all corner cases, and lastly introducing that caching layer to make the time complexity better. The only downside of this is basically when you're using recursion, you might face stack overflow, but all this is something which you can worry about later and you can read about them later on. Okay, talking about dynamic programming, I think this is a super good way to master this concept. And with that, I would wish you good luck. And if you have any questions, please drop them in. All right. Do we have any questions? Some Salman has asked, will this be uploaded to HackerEarth channel? Yes, HackerEarth is working on a lot of mock interview related topics. This is one of them, and they have a series of this stuff. So yeah, they are planning to release it soon. So you can watch all this content on YouTube soon, probably next week. All right. Other other questions? Leaving aside working on problems on CodeChef or LeetCode, what books or website do you recommend to learn DP? Uh, I really am not sure about any book. I mean, in my case, I have not read entire book anyways, and I have mostly learned from Google or something like that. I mean, doing programming problems and watching the tutorials is something which has added value in my skills. In terms of books, I would say Corman is something which I would recommend because it's very detailed and thorough. Other than that, I mean, for websites, any competitive programming website like HackerEarth or CodeChef or CodeFirst, anything would work, and they would be like really useful for you to practice this concept. I mean, there are so many tutorials out there as well. So yeah, just try to Google stuff. I also have a YouTube playlist as well on this concept. So yeah, you have a lot of internet, and I think there's a lot of stuff. So yeah, just use that wisely. All right. Rajesh has asked, what are some of the good resource online? Again, I have answered this question, I think. Apurv have asked, how do I start practicing? Um, I mean, it's quite straightforward. Like, you don't have to be lazy, and you have to basically go to any competitive programming website. For example, HackerEarth. You can sort them by number of submissions in ascending order, and you can just start solving. Like whenever you're stuck, just see the solution code of other people, or you could read the tutorial if that's available. And I would highly encourage you to think yourself, write on paper, and see how this works out for you. I also have listed this in the slide as well if you are able to see that. um, any other questions? uh, I think one of the questions is, should we learn trees first or DP? I would say first learn dynamic programming. It will open up a room for cracking a lot of coding interviews, because not a lot of companies ask trees, but DP is something which you will encounter very soon in your life. Which is the best platform for practice? I think it depends. I think different competitive programming websites are having their pros and cons. For example, HackerEarth is super great in the number of contests that they have, and also I have a lot of friends who were able to get jobs by doing contests on HackerEarth, because they are having a lot of hiring challenges by various good companies in tech, and it really opens a lot of gate for people to just basically grab those opportunities just by performing good in contests. So yeah, I mean, different platforms have different pros. In my case, I was in a good college, so I did not have to worry about whether I would be placed in a good company or not. I mean, almost all good companies were coming to my college, so I was having that opportunity. But I would say if you are not from a very bright college, or if not very good tech companies visit your college, I think hacker challenges is something that you should definitely do. I also have few friends in second or third year which were able to get internships in Adobe just because of doing these contests. All right. Other than that, I would say Codeforces is also pretty good, and AdCoder is something which is a new website, and that's also pretty good. So yeah, um, there might be too much memory hit. Yeah, exactly. So Deva Jyoti has pointed that when we are using recursive solutions, you might consume a lot of memory, which is true, and it's something that you should know. And the other way to solve that problem is not to use recursion, but to basically use simple arrays with a for loop to solve the problem. For example, in the case of Fibonacci numbers, we use the recursive function f of n that simply calls f of n minus 1 and f of n minus 2. You could do something like have an array f instead of a function, and you could do something like for I in range 2 to n, you can do f of I is f of I minus 1 plus f of I minus 2. So in this case, you are not using recursion, and that stack overflow is something that you can avoid. So yeah, that's a good question. Other than that, let's see. Another question is, how often are dynamic programming questions are asked in coding interviews, asked by Benny? And I would say that it's a lot. I mean, I have given interviews with Amazon, Microsoft, our research, and a lot of firms. And dynamic programming is something which I have encountered almost in all of them. Okay, so for any organization, there are a couple of rounds, right? In terms of data structures and algorithms, there might be 3 to 4 rounds depending on company to company. But what I have seen is that dynamic programming is something which is quite common, and that's something which you should definitely invest your time in. All right. Um, Other questions? From where to practice GP, asked by Pratik. I think we have covered that. As I'm saying, go to any online judge, just sort the problems by the tag of dynamic programming, sort them in the descending order of number of submissions, because the more people have solved a problem, it means it might be easy for you to solve that as well. So do that and start solving problems in descending order, and hopefully you would get better and better as you do that. In my case, I remember that for few months I used to really hate this topic. I did not understand anything, and like doing this exact thing, like sorting on the tag of dynamic programming and just doing problems again and again, I think I solved around 7 or 8 problems. And in the next contest, I was so fast in solving a dynamic programming problem. I was super confident, and it really showed that difference in my confidence when I had not done this practice, and I used to just scare I really used to scare dynamic programming a lot. From the list of types of DP, which should I pick first? So Anmol is saying that there are various DP types that we have talked about, and which one you should pick first. So I would say, yeah, 1D DP is something that you should be very familiar with, and slowly you should move on to multi-dimensional DPs. And once you are like really in an intermediate stage where you are easily able to wrap around the recursive thing, I would say at that point of time, it's the time for you to expand your skill set and try to basically dig into other types of dynamic programming. I would say after that, I would encourage you to go into trees and then study DP on trees. Digit dynamic programming is something which is not that familiar in coding interviews. No one is going to ask you that, most probably. So digit dynamic programming is something that you can avoid. DP optimizations is something that you can avoid. You can do them, of course, if you're passionate about math and dynamic programming, but in case of coding interviews, they might not be that relevant. Okay. Uh, I think, do we have any more questions? All right, Apurva is saying this was a great webinar. Thank you. I hope others also enjoyed this. And I would pick last three questions and probably then we can wrap this up. Okay, so one interesting question is asked by Prem. He's saying that how do I predict if the problem fails? Sorry, if the problem falls in DP. So the question is that how do we make sure that this particular problem falls in the DP category? Um, I mean, as a problem solver, I mean, I have few years of experience doing this, so it comes naturally now. Like I don't have to think that whether I have to use segment tree over here or do I need to use greedy approach. It comes naturally. Like as I am tackling the problem, I can see that, yeah, this is how we should do it. But I know that this is something which I used to also have a doubt. Like I really am not that good right now in this. Is there some tip or trick in which I can make figure out that this is a dynamic programming question? So one tip that I would say is the time complexity. Okay, so um, if you have constraints mentioned in the problem, you can say that if n is something close to 10 to the power 6 or 10 to the power 5, something like that, and if you can clearly see that greedy is something which might not work, at that point of time, it's a good hint that you might be using dynamic programming. Or if you can see that um, if it's a maze question or something like where you are dealing with multiple variables and constraints on them, like for example, there is a constraint on n that it's up to 1000 and m is up to 1000. So n into m is something like 1000 into 1000, which is 10 to the power 6, right? So in that case, it might be a signal that maybe it's a 2D dynamic programming problem. All right. So yeah, these are some dirty tricks which might not work out, but I mean, yeah, that's one way to go about it. We can talk about this in detail, probably in some other webinar or question, because if n is 10 to the power 5, it might also mean that n log n should be the expected time complexity of the solution, which means maybe binary search or segmentary or something like that. So yeah, probably this is one of the ways in which you can I would say dirty trick to figure out if it's a dynamic programming problem or not. The other thing is that when you're clearly sure that greedy approach would not work over here, and you have to compute a lot of cases, and it's best in that case to use dynamic programming and let it do the hard work for you. Just come up with the right recursive formula. All right. I think other than that, one question is, are platforms like Lead Code or Interview Bit enough for interview coding rounds? I mean, nothing is enough ever, and more or less than the portal, it's about you, that how much you are familiar with the concept, how much you are confident as a problem solver. I mean, it's not always the case that you will be asked the interviewer will be asking you the questions that you have solved in your past. So more or less, in interviews, it's also very much important that how strong you are as a problem solver. If you are put in difficult situations, how well you are able to make clear assumptions and discuss with the interviewer, and also come up with the different approaches, see why one of them is failing, one of them is working, and probably multiple of them are working, but why the way X is better than way Y. You know what I mean? So you should be able to compare multiple approaches, and it should come naturally to you how to solve problems. It's not just about having a good rating on competitive programming websites, or just able to write code fast and get your solution accepted, or and it's not even about solving 4 out of 4 problems in an interview. It's about how you approach. And as I'm saying, take time, don't just rush on things, don't make jumps. And I really encourage you to be a problem solver in the long run, as it's going to help you a lot. Which is the best language to start with? Jamik Patel has asked that, and I think if you're just starting with programming, I would encourage you to learn Python, because learning Python would not only help you, but it's super easy. I mean, it will help you in a lot of ways. There are a lot of different stuff which you can do easily in Python. Like if you learn C++, doing web development in C++ is not that easy. All right. And if you're in engineering college, I would encourage you to do dynamic program, not dynamic, I mean data structures and algorithms, and side by side also do development work. Okay. So Python is a very good option. And I think if you're starting, if you have the choice, just start with it. Some people might say that Python is slow, but competitive programming websites take care of that. So if for a question you're submitting it in C++ and the time limit is 1 second, if you're submitting it in Python, they increase the time limit to 5 seconds. Okay, so they take care of all those things. So I would really encourage you to learn Python, and I don't think it's a wrong choice at all. Yeah, other than that, Akash has asked whether top down or bottom up approach, which of them is good. So as I'm saying that recursive is something which is very easy for interviewers also to like understand. The only downside is basically the stack overflow which might happen, right? And for that I'm saying that you can very well point that out to the interviewer, that I know that it might face stack overflow, and as long as you explain the concept correctly, you write the code correctly, you handle the base cases correctly, and you also know about stack overflow, I think interviewers will never have a problem that why you wrote it in this fashion and not in like the array one. So yeah, I mean, I think recursive solutions really work better in terms of explaining to the interviewer. All right, last question, guys, and then we'll wrap off. Let me pick some interesting one. Yeah, this is very good. So Vignan has asked how to differentiate between greedy and DP. Wow, it's super difficult, guys, and I think as compared to dynamic programming, greedy solutions are even way tougher. I mean, I can still prove why dynamic programming solution is correct. I can use induction to do that. All right. Proving why a DP solution is correct is very easy. But when it comes to greedy, wow, it's super difficult to prove why greedy solution is working, first of all. So if I have to compare greedy and dynamic programming, greedy solutions are super tough. And even during coding interviews, I have seen myself failing add greedy type of questions, which will only happen if you solve a lot of greedy questions on competitive programming websites or interview or do interviews. Okay, so that comes with experience, and it's very difficult to differentiate between greedy and DP. I really don't have a very bright answer for you. I mean, if you can see, so how do I do that is I try to first use a dynamic programming approach. If that works out, it's pretty good, right? I mean, if everything is fitting into time constraint and memory constraints, it's very good, and I would use dynamic programming. And if it's not working out, like if dynamic programming is taking too much of time or memory, I would then doubt that maybe there is a greedy solution, and only then I would jump towards the greedy approach and start figuring out some greedy or dirty way to fix this problem. So yeah, I think that's the answer for that. All right. Guys, I hope this webinar was fun, and thanks again to HackerEarth for inviting me over here. It was lovely, and I hope this was super useful. And in a couple of weeks, this video would be out on HackerEarth channel, and they also have a couple of other videos all about coding interviews. So yeah, make sure to check that out. And again, you can reach out to me on my YouTube channel. Let me just pull that up again. Yeah, so this is my YouTube channel. You can reach me out over here, comment down, and I will try to reach back and answer few other of your questions if they were not covered over here. So yeah, guys, that's all I had for this webinar. Thanks again for watching and spending your time in this webinar. Thanks for joining, and I will see you sometime later. Bye bye.